So we'll start with a matrix A that's going to be equal to -2, 1, 2, and 5. And then we're also going to have a solution vector B that is, in this case, 5 and 1. So the formulas that go along with this are pretty straightforward. We know that a matrix times an x vector is equal to the solution vector. And the reason why that's useful is because with LU factorization, we can actually turn this into two different matrices, multiply them in such a way where we can end up solving this system of equations without having to do any of like the very long drawn out Gaussian eliminations. Which for this problem, it's going to feel a little silly because it's a pretty straightforward problem, but when you have bigger matrices, it may be a little bit more useful. So this is our base formula that we're going to start with, and then if we take our lower matrix that we're going to solve for, and we multiply that by a y vector, and that will be equal to a b vector. What that's going to look like is an augmented matrix, which we'll get there. But for right now, this is what's important. Okay, and the other pieces after that, we're going to use our upper matrix that we're going to find. We're going to multiply that by an x vector, and that will equal this y vector. So this is kind of the order we're going to go in. This is the base setup for the problem. We're going to find our L and our U, and then we're going to augment our L with our B to get Y, and then we'll augment our U with that Y we found to get our X. That's pretty much what we're working on. So, to get started, let's deal with finding our L and our U. So what I like to do is I'll write my matrix here. And then I like to write my L off to the side, and we know that this is going to be an identity and then a 0 in the top, and all we need to leave is spaces in our bottom triangle. With a 2 by 2, there's only one space we need to worry about. So in this case, we're going to use this first row to eliminate this first number in our bottom row. And then the opposite sign that we used to eliminate that will go in this box over here. So this one's pretty straightforward. All we need to do is add row 1 to row 2, just one row 1 into row 2. Okay, so this is a positive 1, which means we need a negative 1 over here. Okay, so we found our L. Now we don't need to write another place for U because we're about to solve for it from this. So our top row stays unchanged, and then when we add one row 1 into row 2, we get our 0 as expected, and then we have 1 plus 5 is 6, right? So that's actually our U. So there's nothing special we have to do there, we just go straight to a U, which that works out nicely. So now the next piece is we're going to look back over here. We have this L times a y vector is equal to our solution vector. Our solution vector is here, this B vector. So what we're going to take is our L and we're going to augment it with with B. And solving that will get us this y vector. So if I take 1, 0, -1 and 1, and augment that with 5 and 1, now all I have to do is solve this using row reduction. This is already really close to where we want it to be, so this should be pretty straightforward. We're just going to add row 1 into row 2, and that'll get us 1, 0, and 5, and then this will become 0, and then there's 0 plus 1 is just 1, 5 plus 1 is 6. Okay? So now we know that our y vector is going to be this 5, 6 combo. So we can write over here, where we're keeping track of everything, okay, well y is equal to 5, 6. Okay? So the next thing I want to do is we're going to use that y and augment it with our upper triangular matrix, and that'll get us to our x vector, which is our solution. So that's our next piece. We're going to take this u, which is -2, 1, 0, 6. We're going to augment that with our y, which is 5 and 6. Okay, from here we're going to do our normal Gauss-Jordan stuff to reduce this down. So we can take, we'll take 1/6 of this row 2 into row 1 as a negative. So -1/6 row 2 plus row 1. And then at the same time we'll also scale down row 2 by 1/6. And so that'll get us -2 and a 0 as expected. And 1/6 of 6 is just 1, so 5 minus 1 is 4. And then down here, we're going to scale these guys down by 1/6, so we should get 1 and 1. And then all we have to do here is scale down by -1/2. So we'll have -1/2 row 1, and then that becomes just 1, 0, and -2. Then you have 0, 1, and 1 unchanged. So now we can see our x vector is equal to -2 and 1, and that's it.